Okay, now that we went through section 1.3 and 1.4 and learned the 6 trig function definitions, and we learned about quadrantal angles and how to evaluate trig functions that when you cannot draw a right triangle. Now what we're about to do is embark on special acute angles. Okay, remember, when you draw the triangles, they can go in either quadrant 1, quadrant 2, quadrant 3, quadrant 4. Well, there are special angles that are going to come out throughout the whole semester that we need to know their trig function values off the top of our head like that. And those special angles come from special right triangles you saw in geometry class. So, here we go. If you remember in geometry class, to draw a right triangle, you have to have a 90-degree angle. And then the two other angles are obviously acute. They add up to 90. They're complementary. Well, sometimes you could draw a right triangle and have those two angles be the same measure. If you remember in geometry, there was a triangle called an isosceles right triangle. So it was a right triangle. It had a 90-degree angle. But isosceles meant the two sides, the legs, were equal. And if the two legs were equal, it made sense that these two angles are equal. So let's think about this a minute. All three angles in a triangle add up to how many degrees? That's right. All three angles add up to 180. So if you take away this 90, you're left with how many degrees? 90. If you have to split 90 evenly between these two angles, each angle would be 45 degrees. That is what we call an isosceles right triangle. Because that right triangle is going to come up a lot in trigonometry, knowing the sine, cosine, and tangent of 45 degrees is something we need to know off the top of our head. The way I remember it is by drawing the picture. I'm a visual learner. I like to draw the triangles. So 45 degrees is in what quadrant, everybody? Good, quadrant 1. So this triangle is in quadrant 1. So we're not going to label this angle theta. We're being specific. That angle is 45 degrees. And if that angle is 45, we know that angle is 45, which means these two sides are the same length. So here's the part you got to memorize. In an isosceles right triangle, what are the lengths of the sides? Well, if these two sides are the same length, they're going to be each 1 unit. And then to get the radius, the hypotenuse, we would do Pythagorean theorem. So if I do that work over here, 1 squared plus 1 squared equals r squared. What's 1 squared? 1. Plus another 1 equals r squared. What's 1 plus 1? 2. 2 equals r squared. How do you get rid of the square, everybody? You square root, and that means you would reduce it. Can you reduce the square root of 2? No, you cannot. So we would leave the radius as square root of 2. So in a 45, 45, 90 right triangle, the legs are always 1 and 1, the sides that are opposite the 45 degrees, and the radius is always square root of 2. You need to memorize that because that's what you need to find the 6 trig functions of 45 degrees. That angle is going to come up so much this semester, we don't have time for you to do Pythagorean theorem again. You just have to memorize that. So now if I ask you the 6 trig functions of 45 degrees, now you just got to know your definitions. This is your x, this is your y, this is your r. Let's rock and roll, people. Sine is y over r. That's 1 over square root of 2. Cosine is x over r. 1 over square root of 2. Tangent is y over x. 1 over 1. All right? Do the reciprocals. Let's flip. Cosecant is r over y. Square root of 2 over 1. Secant is r over x. Square root of 2 over 1. Cotangent is x over y. 1 over 1. Was that hard? No, not at all. The problem is, for you to give me the 6 trig function values of 45 degrees, you have to memorize that picture. You have to know that triangle by heart. Or, option 2 is, you memorize these 6 answers. So it's your choice. You either memorize a picture or 6 answers. Now, the problem with all 6 of these answers is they're not simplified. I'm not going to accept 1 over square root of 2 as neither is your homework. We'll rationalize that. We'll multiply that by square root of 2. So the sine of 45 degrees is always square root of 2 over 2. That means the cosine of 45 degrees is the same thing. We're going to rationalize it. Get square root of 2 over 2. The tangent is just 1. The cosecant is just square root of 2. The secant is just square root of 2. The cotangent is 1. So here's your decision to make. You're either going to memorize this picture and know the 3 sides of the isosceles right triangle so you can define your definitions, or you're going to memorize these 6 answers by heart. Think about this. What quadrant are we in? 1. What do you know about all the trig functions? They're all what value? Positive. Because everyone's positive in quadrant 1. Now, that's not too bad, but that's not the only special right triangle. So here's our problem. Let's continue. Another special right triangle is the 30, 60, 90. In geometry, there was a right triangle that was 30, 60, 90, which meant if the angles were different measures, the sides were not equal. Okay? When I draw a 30, 60, 90 right triangle in quadrant 1, if I make the angle here 30, that makes this angle up here 60, and that makes the right angle 90. There is a relationship. If this is the smallest side, then across from it, if this is the smallest angle, then across from it would be the smallest side. If this is the largest angle, then across from it would be the largest side. So guys, this is one of your special right triangles you learn in geometry. You need to memorize for me the relationship of the 3 sides. If 30 degrees is the smallest angle, then this is the smallest side, and it starts out with 1, just like here. If this is the largest angle, 90 degrees, this is the largest side, it's going to be the number 2. And then 60 degrees is in the middle, so this side would be in the middle, which is square root of 3. And we talked about this already. Square root of 3 is roughly $1.70. $1.70 is bigger than 1, but less than 2. So that's what I memorize. Memorize that triangle. So now if I ask you the 6 trig functions of cosine of 30 degrees and sine of 30 degrees and tangent of 30 degrees, see how the 30 degrees is in the corner here? I'm doing 30 degrees. I'll do my definitions. Here's my x, here's my y, here's my r. Sine is y over r, 1 over 2. Cosine is x over r, square root of 3 over 2. Tangent is y over x, 1 over square root of 3. I'll do my reciprocals. Cosecant is r over y, 2 over 1. Secant is r over x. R is 2, x is square root of 3. Cotangent is x over y, square root of 3 over 1. Okay? Are all 6 of those fractions acceptable? Tangent of 30 is not. We'll rationalize it. So we'll multiply by square root of 3 over 3. So there we go. Square root of 3 over 3. Cosecant is not acceptable. 2 over 1 is 2. Secant is not acceptable. We have to rationalize it. And we'll get 2 square roots of 3 over 3. Cotangent is not acceptable. That's just good old square root of 3. So if I ask you the 6 trig function values of 30 degrees, you should know these answers. Now you have a decision. Do you want to memorize these 6 fractions, or do you memorize looking at this picture? I'm a picture person. I like to draw the picture and then do the definitions, keep practicing them. If you want to memorize that, but now you got 6 and 6, that's 12, and we're still not done. Because who says in a 30, 60, 90, you have to put the 30-degree angle here to be the acute angle? Let's make the 60-degree angle the acute angle. So it's the same triangle, but now I'm putting 60 degrees here. Oh, that picture's not drawn right. Let me fix that, because it shouldn't look isosceles. That's a bit better. So there's my 60 degrees. There's my 30 degrees. Y'all with me? The rule is, if that's 30 degrees, this side across is the smallest side. It is 1. If this is 90, the side across, the radius, is the biggest side, 2. And the side in the middle is square root of 3. Now in this picture, when you make the acute angle the 60 degrees, now the x is 1, the y is square root of 3, and there's your r. So when I do the sine, cosine, and tangent value of 60 degrees, it is not going to be the same 6 fractions. Because if you look, the triangles, the x's and y's switched. You'll see that? So if we do the sine is 60, y over r, square root of 3 over 2. Cosine is 60, x over r, 1 over 2. Tangent is 60, y over x, square root of 3 over 1. Cosecant is 60, r over y, 2 over square root of 3. Secant is 60, r over x, 2 over 1. Cotangent of 60, x over y, 1 over square root of 3. Well, are all 6 of those fraction values acceptable? Yes, yes, no. Square root of 3 over 1 is square root of 3. 2 over square root of 3, no. Rationalize. Multiply by square root of 3, so that's 2 square roots of 3 over 3. 2 over 1, no. That's 2. 1 over square root of 3, no. Let's rationalize. Square root of 3 over 3. So here's the moral of the story. You have a decision to make right now. You either A, memorize these 18 fractions. You know all those answers. Or B, you memorize the setup of the 45-45-90 triangle and the 30-60-90 triangle. And draw them. If you can draw the triangles, all these triangles, 45, 30, and 60 are all drawn in quadrant 1 because that's where 45, 30, and 60 degrees are located, right? And if you're in quadrant 1, all the trig function values are positive values. They're all positive fractions. So if you just know for a 45, 45, 90, the sides are 1, 1, square root of 2, and you know for a 30, 60, 90, the sides are opposite the 30s 1, opposite the 60s square root of 3, opposite the 90s 2, you got it made. Because if you draw the picture, then you can do your definitions. I don't care which way you memorize it, it just needs to be known. Now the problem is you're going to be like, when we go on later on this semester and we start doing our calculator work and we start learning to type this in, the calculator is not going to spit out square root of 3 over 2. It's going to spit out a decimal, and that is going to be totally unacceptable. So I know what you're thinking. Some of you are thinking, oh, I think I can use my calculator and cheat. No, you can't. Because you have to have these answers written exactly as these fractions to be acceptable. Now, how are we going to use this knowledge? Okay, let me erase. I'm going to leave the pictures up there. But let's look at our notes. We have some examples. All right, so I'm going to leave the diagrams. But if everybody looks at example 1b, it says, evaluate the expression without a calculator. Evaluate means give me a value. And a value is a number. When you put a value on your house or on your car or on a piece of jewelry, you put a number amount on it. You evaluate it all the time in algebra. If I had 2a plus 3b, and I told you a was 4 and b was negative 2, what did you do? You substituted those numbers in and worked it out. The same thing here. I want to evaluate this expression. Cosine squared 30 degrees plus sine squared 30 degrees. And it said, no, sine squared 60 degrees. Apologize. All right, so that's 1b. And it says you cannot use your calculator. And the reason why is, again, I need to see the work. I need to see you understand what these expressions mean. First thing I want you to notice is the square. When they put the square with the trig function, it's squaring the whole thing. So I'm going to rewrite this so you understand it. This says the cosine of 30 degrees squared. When they put this square with the word sine, they're squaring the whole expression. This is the sine of 60 degrees squared. It does not mean they're squaring the angle. They're not saying 30 degrees times 30 degrees is 900 degrees. That's not what they're saying. They're saying find the value of this, the fraction, and then take the fraction and square it. Okay? So we want to know the cosine of 30 degrees, and then we want to square it. So guys, look at me. This is the way I memorize it. I want to know the cosine of 30 degrees. I need my 30-degree triangle. Right there. If I put 30 degrees here, the side opposite is always 1. The side opposite the 60 is always square root of 3. The side opposite the 90 is always 2. That's the picture I need. And then I'm going to do cosine. Cosine is x over r. So I know by looking at that picture, the cosine is square root of 3 over 2, and then I'm going to square that. If I want to know the value of sine of 60 degrees, instead of memorizing all 18 of those fractions, I go to my 60-degree triangle, which means the 60 degrees has to be put here. If that's 60 degrees, the side opposite is square root of 3. That means that's 30 degrees. The side opposite is 1. The radius is always 2. If I want sine, my definition of sine is y over r. Square root of 3 over 2. Because 30 degrees and 60 degrees are in quadrant 1, both of these fractions are positive. Y'all with me? Great. Now just do the arithmetic. What does squaring mean? To multiply this by itself. Multiplying fractions is no problem. Top times top, bottom times bottom. What's square root of 3 times square root of 3? It's square root of 9, which is 3. What's 2 times 2? 4. And we're going to square that one. Same thing. Now, this is adding. Adding fractions easy as can be. All you need is an LCD. What's my least common denominator? 4. You write the bottom, you add the top. What's 3 plus 3? 6. Am I going to accept 6/4? No, it's got to be reduced to 3/2. We just evaluated the trig expression. We don't need a calculator. We need to understand what these statements mean and how to work it. Let's do one more in the notes. Let's go to that example D. D looks good. Okay, I'm going to erase this and we're going to go to example D. Let's do one more. D says the cosine of pi over 2 plus 2 times the tangent of pi over 4 minus the sine of pi over 3. All right. Trig is a building block. Everything we've done so far is building. We're never going to lose these facts that we learned in the beginning of this course. First of all, if you look, here's the trig functions. So behind them is an angle measurement. Always when you write trig, there's always an angle measurement behind it. What units is this in? That's right. It's not degrees, it's radians. And that's in radians. And that's in radians. Well, we have a hard time because we're not familiar with radians. We'd rather change these to degrees. So over to the side here, I'm going to say, okay, if I have pi over 2, what is the conversion to change that to radian measure? Well, if I want this to be from radians into degrees, I want to get rid of the pi. I'm going to multiply by 180 degrees over pi. Remember that conversion? And what happens to the pi symbols? They cancel out, and 180 divided by 2 would give you 90 degrees. Now, let me show you all a trick. Now that you know the actual conversion, there's a quick way to do this. If you remember back in section 3.1 when we defined radian measure, we said if you had a straight angle which was 180 degrees, it equaled pi radians. That means every time you see the pi symbol, it stands for 180 degrees. So a quick way to change radian measure into degrees is every time you see the pi symbol, replace it with 180 degrees. And 180 degrees divided by 2 is 90 degrees. I wanted to wait to show that to y'all till you got familiar with radians. Over here, this is plus 2 tangent. This is pi over 4. So according to section 3.1, 180 degrees can be replaced when you see a pi. So that's 180 degrees over 4, which is 45 degrees. Minus sine, that's pi, 180 degrees divided by 3 is 60 degrees. So in order to evaluate a trig expression, the first thing you need to do is convert radians to degrees, so you understand it. Now, looking up the cosine of 90 degrees is not from this section 2-1, it's from the previous video. 90 degrees is a quadrantal angle. What does that mean? It means the terminal ray falls on one of the axes. If I said draw a 90-degree angle, you all know if we drew a 90-degree angle, here would be the initial ray, and the terminal ray would land here. And we've already discussed that if the terminal ray lands on one of the axes, there's no way to draw a right triangle. So to evaluate the cosine of 90, we have to look it up on what we call the unit circle. Remember we drew the circle? And we listed the 4 coordinates, and they are 1, 0, 0, 1, -1, 0, 0, -1. Do you remember that? I hope you did. So if we're going to look up the cosine of 90, we're going to use the coordinate where the terminal ray landed. The terminal ray lands here, so we're going to use 0, 1. This is your x value. This is your y value. Cosine stands for x over r. Our x value is 0, and on the unit circle, the radius is 1. So that just becomes a 0. Make sense? Plus 2. Now we want to look up the tangent of 45 degrees. 45 degrees is in quadrant 1, so we know this answer is going to be positive. But to look up the tangent of 45 degrees, we need that special triangle. In a 45, 45, 90, the two sides are 1. The radius is square root of 2. Memorize that. What does tangent stand for? Tangent stands for y over x. So that would be 1 over 1. Well, that's going to be a 1, and 1 times 2 would just give us 2. Now we're going to look up the sine of 60 degrees. So if we're looking up the sine of 60 degrees, that's in quadrant 1. We know that answer, whatever we get out, is going to be positive. If we go to 60 degrees, right here, we know the side opposite 60 is square root of 3. The side opposite of 30 is 1. The hypotenuse is 2. The word sine stands for y over r. There's your y, there's your r. So this is minus square root of 3 over 2. So what we want to do is when we evaluate a trig function, we are replacing the function with a number. Make sense? Evaluate. You give me a value out. Now, we all know 0 plus 2 is 2. The problem is with 2 minus square root of 3 over 2. That's an unacceptable answer. In math world, all answers have to be one fraction. This is subtracting. The biggest boo-boo I see you make here is you want to cancel this 2 with this 2. Canceling is division, guys. You cannot divide if you're connected by subtraction. The only time you can divide is multiplication. If I wrote this, 2 square roots of 3 over 2, you could cancel because this is connected by multiplying, and if you're connected by multiplying, you can divide. But this is subtracting. And adding and subtracting fractions, you need a least common denominator. What's the least common denominator of 1 and 2? Well, it happens to be 2, right? So if I change my denominators to 2, how does a 1 become a 2? I multiplied by 2, so 2 times 2 would be 4. This stayed 2, so it stays a square root of 3. So now we write it as one fraction. The denominator's 2. Can you physically subtract 4 minus the square root of 3? No, you cannot subtract a whole number with the root, so you write it as the numerator. And that's the acceptable answer. You're never going to get that out of a calculator. And that's the thing, okay? I'm warning y'all. In your homework, it will not accept decimal answers. That's all the calculator is going to spit out right now. So if you try to, on your own, figure out how to use your calculator, you're going to get out decimals, and they're unacceptable. Right now, our focus is learning definitions and what all these words mean. You really need to start memorizing facts and memorizing your triangles. All right. Catch you in the next video.